Well, this is it. Here we are. This is the lesson that gets you into Algebra 2. Even though this is Algebra 1 curriculum, factoring quadratic trinomials is the most important tool to get into Algebra 2, to succeed in pre-calc, and to succeed in calculus. As you can see, this is my favorite thing to teach. So what we're going to be doing is we're going to be reviewing how to FOIL. We're going to be multiplying binomials, we're going to be combining like terms, but really pay attention to the details. So if you guys remember how to FOIL, please do so. I've written it twice to show you that if you like FOIL or if you like the rectangle, it doesn't matter, I'll oblige you. So if you like the FOIL method, x times x is x squared. X times 3 is positive 3x. 7 times x is positive 7x. And 7 times 3 is 21. We're going to combine the like terms in the middle. I'm just going to circle them lightly. And that's going to get me x squared plus 10x plus 21. If you like it with the rectangle, let's just say I do it like this. You could have done x plus 7 on top and x plus 3 on the side. It doesn't matter. Because either way, you're doing x times x is x squared. 7 times x is plus 7x. X times 3 is positive 3x. And 7 times 3 is positive 21. And where are the like terms? In the diagonals. So we get the same thing. X squared plus 10x plus 21. I'm going to write that a little bit neater. That plus seems to be flying a little bit. But yeah, so either way we get the same result. And I'm going to have you guys do the same exact numbers 3 more times. See if you guys can do x minus 7 times x minus 3 independently. And when you're done with that, see if you guys can do x plus 7 times x minus 3 and x minus 7 times x plus 3 independently. So I'm going to show the notebook. So I want you guys to be able to do these 3 problems independently using FOIL or rectangle. It doesn't matter, whichever you like. Okay, so let's say I do problem number 2. So let's say I start with the rectangle method. I'm going to do x minus 3, x minus 7. X times x is x squared. X times negative 3 is negative 3x. X times negative 7 is negative 7x. And negative 7 times negative 3 is positive 21. So I'm going to alternate. So in the end, I still get x squared. I'm going to combine these like terms, negative 3x and negative 7x, and get negative 10x and plus 21. So if I did this using FOIL, x times x is x squared. X times negative 3 is negative 3x. Negative 7 times x is negative 7x. And negative 7 times negative 3 is positive 21. You still get the same result. X squared minus 10x plus 21. Okay. Moving on to review problem number 3. Again, I'm looking at the clock and I'm trying to save time. I don't want to go over this in detail, but I don't want to go over this in thorough detail since we did this in the previous test, but let's just say I pick one. I'm going to do x times x is x squared. Negative 3 times x is negative 3x. X times positive 7 is positive 7x. Negative 3 times positive 7 is negative 21. So in the end, I'm going to get x squared minus 3x plus 7x minus 21. And if I combine the like terms, I'm going to get x squared plus 4x minus 21. Okay? Same numbers, different result. Moving on over here, I did the rectangle for this problem, so I'll do FOIL for this one. Let's say I do this. X times x is x squared. X times positive 3 is positive 3x. Negative 7 times x is negative 7x. And negative 7 times positive 3 is negative 21. And if I circle the like terms, I'm going to get x squared. Positive 3 and negative 7 form negative 4x and minus 21. So there's a reason why I reviewed a concept from 2 tests ago for this particular unit, because this is one of the most important things you're ever going to learn in high school math, especially if you want to get a college degree. So if I just go over the answers of all these problems, I got x squared plus 10x plus 21. I got x squared minus 10x plus 21. X squared plus 4x minus 21, but also x squared minus 4x minus 21. So let's notice this time, once we've foiled them out or rectangled them out, let's notice the details. I'm going to get my red, and I'm going to do this piece by piece. So we've got an x on the front of this binomial and an x on the front of the second binomial. But in particular, I'm going to pay attention. You know what I should get? I should probably get a highlighter, not a... So if I pay attention to positive 7 and positive 3, what do I notice about positive 10 and positive 21? So just start to think to yourself, what is the relationship between positive 7, positive 3, and positive 21? Then, what's the relationship between positive 7, positive 3, and positive 10? Well, 7 times 3 is 21, and 7 plus 3 is 10. That can't be a coincidence. Let's take a look at problem number 2. I'm going to focus on negative 7 and negative 3. Then I'm going to highlight negative 10 and positive 21. What's the relationship between negative 7, negative 3, and positive 21? What's the relationship between negative 7, negative 3, and negative 10? Well, negative 7 times negative 3 is positive 21, and negative 7 plus negative 3 equal negative 10. That can't be a coincidence. Let's take a look at this one. X plus 7 times x minus 3. I'm going to highlight the positive 7. I'm going to highlight the negative 3. I'm also going to highlight the positive 4. And I'm going to highlight the negative 21. What do you notice about positive 7, negative 3, and negative 21? Then, what do you notice about positive 7, negative 3, and positive 4? So, positive 7 times negative 3 is equal to negative 21. Boom. However, positive 7 plus negative 3 is also equal to positive 4. That can't be a coincidence. Finally, for the last review problem, if I've got x minus 7 times x plus 3, and I'm going to highlight the second part of the binomials, and I'm going to highlight the coefficients for the middle term and the third term. What do you notice about negative 7, positive 3, and negative 21? Negative 7 times positive 3 is negative 21. And what do you notice about negative 7, positive 3, and negative 4? Negative 7 plus 3 is negative 4. So, am I wasting your time? Nope. This is all it takes to get into Algebra 2. Obviously, it's a little bit harder than this, but if you have the confidence in yourself, knowing the relationship between the middle term, the third term, and how to split these up, you're going to do really well for the rest of the school year. I assure you that if you want to get an A in the fourth quarter of my course of Algebra 1B, all you need to do is know the relationship of how to multiply to a certain number and how to add to a certain number with two specific whole numbers. So if we take a look, before, what you had to do was multiply by FOIL or rectangle, then combine the like terms, and you got something along the lines of x squared plus some bx plus c. So the b and the c are the numbers, the coefficients. B is a coefficient, c is a constant. Now, I'm not going to make you multiply and combine like terms. I'm going to give you the x squared, the plus bx, and the plus c, and now your job is to make this a multiplication problem. We're going backwards. We're taking x squared plus bx plus c, and we want a multiplication problem out of this. You know why? Because we love the zero product principle. It's going to come back, but for now, you need to factor, factor, factor. So the strategy is, if you've got x squared plus bx plus c, and you want a multiplication problem out of this, the strategy is you need to find the two whole numbers such that they multiply to c, they multiply to the third number without the x, and they add to the middle term coefficient. So they multiply to c and add to b. They multiply to the third term, they add to the middle term. I'm looking for two whole numbers that satisfy not one, but both requirements. Do you understand? Okay, so they're like little puzzles. I remember when I was in 11th grade and I did this in Algebra 1 and I took Algebra 2, and my 11th grade teacher for Algebra 2 was like, how many of you guys like to factor in your free time? It's okay, raise your hand, be honest, and I'll be honest, I was kind of one of those kids where, yeah, this is a lot of fun. So these are like little puzzles. So let's start off with problem number 1. So the problem is x squared plus bx plus c, and I want a multiplication problem. So remember that the 10 is the c and the 7 is the b. So I'm going to make them all positive today, just so I want to warm up and get you guys comfortable with this. So for the sake of argument, I want two numbers that multiply to positive 10, add to positive 7. Make that table. One of the worst things you can do in this unit is stare into space. If you don't know the combination in 3 seconds, make that table. If you want to go to Algebra 2 and you don't know how to factor a quadratic trinomial, make that table. It doesn't take It doesn't take memorization, it takes effort. You give a little bit of your effort to me, and you will do well for the rest from now until June. So let's list out the factors of 10. So always start with 1 and the number itself. 1 times 10. So 1 times 10 is 10. However, 1 plus 10 is 11. Is that what we want? Nah. So let's move on to the next one. Let's do 10. So my next move would be to do, I'm just following the protocol just to show you what I want. So I want 10 divided by 2. Sorry, 10 divided by 2. And that's going to get me 5. Okay, well, let's try 2 times 5. 2 times 5 is 10, but 2 plus 5 is 7. Is that what I want? Yeah. So what does that mean? That's the winning team. I put a little check mark on that one. So what that means is that that this can be factored. Let me put a little circle on this just so I don't lose my space. So what does this mean? I can factor x squared plus 7x plus 10 into x plus 2 times x plus 5. And if you don't believe me, FOIL it yourself. So I've got x plus 2 times x plus 5 here. If I FOIL this out, x times x is x squared. X times 5 is 5x. 2 times x is positive 2x. And 2 times 5 is 10. I'm going to combine the like terms in the middle. And I get what I want all along. X squared plus 7x plus 10. Do you understand? So it's that simple. All you do is, instead of foiling and combining like terms, now that I've had expanded form, I want it into factored form. It's so useful. So now, let's see if we can do the second one together. Once again, what am I looking for if I want to factor this into a multiplication problem? The C is 5, the B is 6. So I'm looking for two numbers that multiply to positive 5 and add to form positive 6. Remember, it's a unique pair of whole numbers. What are they? Well, I'm always going to try 1 and itself, so, that never works. Let's give this a shot. 1 times 5. Well, 1 times 5 is 5. 1 plus 5 is, oh, you got to be kidding me. You got to be kidding me. That actually worked. 1 times 5 is 5, but 1 plus 5 is 6, and we win. Oh, it's a thing of beauty. So therefore, how does this factor? Well, the combination that multiplies to 5 and adds to 6 is 1 and 5. So this is x plus 1, x plus 5. And I just kind of did one of my own pet peeves. When I ask you to factor, I don't want numbers. I want binomials. So when I ask students to factor, chances are like, hey, can you factor x squared plus 7x plus 10? I get 2 and 5. No, 2 and 5 is not the answer. Factor this into x plus 2 times x plus 5. Hey, factor x squared plus 6x plus 5. 1 and 5. No, x plus 1 times x plus 5. When I tell you to factor, I want binomials. Okay? See if you can do this problem independently. Okay? Now, what multiplies to 12 and adds to 7? Make that table. 1 times 12. 1 times 12 is 12, but 1 plus 12 is 13. That didn't work. Let me try divided by 2. Can I do 12 divided by 2? Yeah. 12 divided by 2? 2 times 6. 2 times 6 is 12. 2 plus 6 is 8. Is that what I want? Nah. Let me try some more. Let me try divided by 3. 12 divided by 3, is that a whole number? Yeah. 3 times 4. 3 times 4 is 12. 3 plus 4 is 7. We have a winner. So we found the winning combination that multiplies to 12 and adds to 7. We win. So what does this factor into? Not 3 and 4. I want x plus 3 times x plus 4. Now I can hear some of you guys having questions. Could I write problem number 1 as x plus 5 times x plus 2? Can I write problem number 2 as x plus 5 times x plus 1? Or can I write this as x plus 4 times x plus 3? And the answer is yes. I want to see a positive in front of the 3. I want to see a positive in front of the 4. And you can switch them out. X plus 4, x plus 3, same thing. Okay? See if you guys can do problem number 4 independently by pausing the video. Once again, make that table. I know it's day 1. Make that table. Okay. So I'm looking for the combination of whole numbers that multiply to positive 24 and add to positive 10. What two numbers multiply to 24 and add to 10? Make that table. Let's try 1 times 24. 1 times 24 is 24, but 1 plus 24 is 25. That's not what I want. I want 10. Let's try divide by 2. 24 divided by 2. 2 times 12. 2 times 12 is 24, but 2 plus 12 is 14. That's not what I want, but notice I'm getting closer and closer to 10. Let's say I do divide by 3. Can I do 24 divided by 3? Yeah. 3 times 8 is 24. 3 times 8 is 24, but 3 plus 8 is 11. Is that what I want? Nah. Let's go down and do divide by 4 if I can. 24 divided by 4 is 6. So 4 times 6 is 24. 4 plus 6 is 10. We win. So I'm going to put a check. I like these two. So what does x squared plus 10x plus 24 factor into? I'm going to use that winning team to factor this into x plus 4 times x plus 6. If you like to write this as x plus 6 times x plus 4, be my guest. Okay. All right. This time, sorry about the shaking camera, see if you can do these two problems independently. Factor x squared plus 8x plus 16 and factor x squared plus 6x plus 9. All right, let's take a look at this one. I'm looking for two numbers that multiply to positive 16 and add to positive 8. What two numbers multiply to 16 but add to 8? So let's start with 1 and 16. 1 times 16 is 16, but 1 plus 16 is 17. Is that what I want? No. Let's try divided by 2. Can I do 16 divided by 2? Yeah. 2 times 8 is 16, but 2 plus 8 is positive 10. Is that what I want? No. Can I do 16 divided by 3? Well, it's a decimal, so I don't count it. Can I do 16 divided by 4 then? Four times 4 is 16, but 4 plus 4 is we have a winner. So I'm going to check that combination. So how does this factor? Well, personally, I like x plus 4 times x plus 4. I'm okay with this because it shows me that 4 and 4 are the winning combination. However, if you go to a standardized test or you go to a public school, they probably have their curriculum set. Let's simplify this to form x plus 4 quantity squared. I can see where they're getting at with this, but when, first off, they're the same thing. But what I would say is this shows me that the combination is 4 and 4. And I would actually find this easier in pre-calculus and calculus to expand it out. Both are great, but I will accept either one of these two solutions. Okay, now looking at problem number 6, what two numbers multiply to positive 9 and add to positive 6? Well, let's look at the obvious combination. 1 times 9. 1 times 9 is 9. 1 plus 9 is 10. Is that what I want? No. Can I do 9 divided by 2 and get a whole number? No. If it's a decimal, then forget it. Can I do 9 divided by 3 and get a whole number? Yes. In fact, 3 times 3 is 9. 3 times 3 is 9, but 3 plus 3 is, we have a winner, 6. So this is the combination that I want. So how do I factor x squared plus 6x plus 9 if that's my winning team? Well, once again, two ways. X plus 3 times x plus 3, I will accept that. You can also write this as x plus 3 quantity squared. It's the same thing. All right, let's take a look at the last two problems of the day. Well, let's take a look at number 7. X squared plus 11x plus 30. I'm trying to find the winning combination that multiplies to 30 and adds to 11. So I made the last two problems medium level difficulty and then a little bit more difficult because I wanted to see if you guys could make that table. You don't get better at this by staring at it. And I mean this with full sincerity. Practice, practice, practice. The best advice that I can give you with factoring quadratic trinomials, oddly enough, you guys are going to laugh, but the best advice I can give you is to fail. List your failures. Notice the combinations that don't work, and then it'll lead to the combination that does work. So let's try 1 and 30. 1 times 30 is 30. 1 plus 30 is 31. That's not what I want. I'm going to write it down because it's going to stimulate my brain. Can I divide by 2? Can I do 30 divided by 2? Yeah. 2 times 15. 2 times 15 is 30, but 2 plus 15 is 17. That's not what I want, but you notice how much closer I got to 11. Let me try 3. Can I do 30 divided by 3? Yeah. 3 times 10. 3 times 10 is 30, but 3 plus 10 is 13. Not quite 11, but we're almost there. Can I do 30 divided by 4? No, that's 7.5. That's a decimal. Let me try 30 divided by 5. Can I do 30 divided by 5? Yeah. 5 times 6. 5 times 6 is 30. 5 plus 6 is, there we go. It took me four chances, 4 tries. Fail, 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 succeed. And how do I factor x squared plus 11x plus 30 into 2 binomials? The winning team is x plus 5 times x plus 6. Okay? Even this one kind of threw me off. This was from the book. X squared plus 17x plus 60. Even I was like, do I know this? And I was like, oh yeah, I do. So what I did was I made a table. I wanted to figure out what multiplies to positive 60 and adds to positive 17. What two numbers multiply to 60 and add to 17? Well, I don't know. So let me just try my failures. 1 times 60. Even though 1 times 60, I know it's not going to work, I'm going to stimulate my brain. 1 times 60 is 60. 1 plus 60 is 61. Not what I want. Can I do 60 divided by 2 then? Yeah. 2 times 30 is 60. 2 times 30 is 60, but 2 plus 30 is 32. Not what I wanted, but you see, I'm getting closer and closer to that winning team. The wider I go, to the closer I go, I'm going to get that winning team. I'm going to divide by 3. 3 times what is 60? 3 times 20. 3 plus 20, though, is 23, closer to 17. Let me try divide by 4. Can I do divide by 4? Yeah. 4 times 15 is 60. 4 plus 15, though, is 19. Ah, not there. Not there. Let me try if I can do, I did 1, 2, 3, 4. Let me do divide by 5. Can I do 60 divided by 5? Five times 12 is 60. Oh, but 5 plus 12 is 17. That checks out. That's our winning team. So, how do I factor x squared plus 17x plus 60? I can write this as x plus 5 times x plus 12. Tomorrow, we're going to be doing problems more than just positive combinations. Hope you guys have a great day.